Hello everyone, welcome to new class. Today's class is about the problems related to network functions. So in the previous class we have discussed about network functions. So today's class is about the problems related to network functions. So let us do the problems. For the network shown, determine the transfer impedance. So this is the given network, and the values are 10 ohm, 20 ohm, 2 Henry for the inductance and a 5 farad capacitance. So our first step is we have to convert this time domain functions into S domain functions. So first of all convert this network into, that is we have to transform this network into S domain. So for that redraw the network. So here 10 ohm is 10, then 20 ohm is the value 20, then 2 Henry. So it will be 2S. Then 5 farad. So capacitor is 1 by Cs and inductor is L into S. That is we have already discussed in the previous class, that is resistance is converted into value R and inductor is converted into value L into S. Capacitor is converted into the value 1 by Cs. So 5 farad will be 1 by 5S. So this is the transform circuit. So this is transform network. Now we have to find the transfer impedance. So what is transfer impedance? Transfer impedance is Z, Z of S. So this is one port network. So transfer impedance is Z of S. If it is two port network, then it will be Z12 or Z21 like that. So here this is one port network. So transfer impedance here is Z of S, that is V of S divided by I of S. So we have to find this value, and here, so this is 1 dash, and here we have to find the value of Z of S. So Z of S we can find very easily because here this capacitor and resistor are in series, which is in parallel to this inductor and which is again in series with this 10 ohm resistor. So we can find its value here. So Z of S here is, that is 1 by 5S plus 20, that is these two in series, which is in parallel with the 2S and which is in series with the 10. Now we can simplify this one. That is, here we will get 1 plus 100S divided by 5S. Then which is in parallel with the 2S. So that means into 2S divided by again 1 plus 100S divided by 5S plus 2S, and which is in series with 10. Now again we can simplify this one. So here this 5S and 5S get cancelled, and rearranging we will get here 200S square. 200S square plus 2S, then divided by, here we will get 10S square. 10S square plus then 100S plus 1, which is in series with 10. Now again we can simplify this one. That is here 200 s square, that is take the LCM. So here we will get 200 s square plus 2s plus multiply this one, that is 100 s square plus 1000 s plus 10 divided by this one, that is 10 s square plus 100 s plus 1. 200 and 100, 300 s square. So 300 s square plus 1000 and 2s plus 10 divided by 10 s square plus 100 s plus 1. So this is the value of Z of S, that is the transfer impedance. Let us do another problem. For the two-port network, determine the driving point impedance Z11 of S, driving point admittance Y11 of S, and transfer impedance Z21 of S. So this is the given network, and look here, this is already transformed network. So here we have to find the values of Z11, Y11, Z21. So for that, here we have to apply KVL. So consider this as I1 of S. So for the first loop, that is for the loop 1, applying KVL, we will get V1 of S, then minus 10 into I1 of S minus 2S into I1 of S, because there is no element in the second loop. So it will be I1 of S through this 2S inductor, and that is equal to 0. That is V1 of S equal to I1 of S into 10 plus 2S. Then applying KVL for the loop 2. So what will be V2 of S? So V2 of S is equal to 2S into I1 of S. Now we can find the values of Z11, Y11, etc. So what is driving point impedance? Z11 of S. So Z11 of S is V1 of S divided by I1 of S. So let this equation be 1 and this is 2. So what is V1 of S divided by I1 of S? That is from this equation, that is from the first equation, we have V1 of S divided by I1 of S is equal to 10 plus 2S. Then what will be Y11 of S? So it is the reciprocal of Z11 of S, and that is 1 divided by 10 plus 2S. Next, we have to find the value of transfer impedance Z21 of S. That is Z21 of S is equal to V2 of S divided by I1 of S. Then what is V2 of S divided by I1 of S? That is from this equation, from equation 2, we have V2 of S divided by I1 of S is equal to 2S. So these are the values we have to find: Z11 of S, Y11 of S, and Z21 of S. Let us do another problem. For the network shown, determine the transfer functions G21 of S, Z21 of S, and Y11 of S. So this is the given figure. So this is also transformed network. So we have to find the transfer functions G21 of S. What is G21 of S? It is the voltage transfer ratio. So for that, here also we have to apply KVL. So for the loop 1, applying KVL, we will get V1 of S minus 5s into I1 of S, then minus 1 by 2s into I1 of S equal to 0. That is V1 of S is equal to 5s plus 1 by 2s into I1 of S. We can simplify here, that is 10s square plus 1 divided by 2s into I1 of S. So this is the first equation. Then applying KVL for the loop 2. Then we will get V2 of S. V2 of S is equal to 1 divided by 2s into I1 of S. So this is the second equation. Now we can find the values of G to 1 of S, that is voltage transfer ratio G to 1 of S is equal to V2 of S divided by V1 of S. So here this is V1 of S and this is V2 of S. So divide equation 2 with equation 1. So we will get V2 of S divided by V1 of S. That is I1 of S get cancelled and 1 divided by 2s divided by 10s square plus 1 divided by 2s. So after simplifying, we will get 2s get cancelled, that is 1 divided by 10s square plus 1. So this is G21 of S. Now we can find the value of Z21S. Z21 of S is equal to V2 of S divided by I1 of S. So from the second equation we have V2 of S divided by I1 of S is equal to 1 divided by 2S. Then what is Y11 of S? So next question is to find the value of Y11 of S. So Y11 of S is the admittance, that is I1 of S divided by V1 of S. So from the first equation we have I1 of S divided by V1 of S is 2S divided by 10S square plus 1. So these are the values of G21 of S, Z21 of S and Y11 of S. So that is about the problems related to network functions, and let us discuss more problems related to this network functions in the next class. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.